Hi, this is Mr. Max. I gave my grade 11 learners a revision test based on graphs of functions. All right, and this is the corrections of that test. So the first question I had given you a function f of x is equal to 3 plus square root of x, and x should be greater or equal to 0. So simply what that means is that you can't have the square root of a number like -2. It does not exist. Okay, it's not possible. All right, so whatever that number is, it should be at least 0 because the square root of 0 exists. Okay, you can check this with your calculator, or in numbers that are bigger than 0. So that is just information that makes sense that we put out there so that you can know that we expect our answer of x to be at least satisfying that condition. Now, suppose you take this function and you let it equal to 7. Some of you could not do that. Somebody say 3 plus square root of x is equal to 7. Now, the idea is to make x the subject of the formula. Get that 3, then get rid of the square root by squaring. So the answer there was 16. Now, when I expected you here to find the inverse of the function, you take your letters, you swap them around. Remember, the idea now is to make y the subject. So you must put the x minus 3 in brackets and then you square it. But this is not the answer. Our answer should now contain the inverse, okay, not y. The second question here dealt with speed time graph. Now the graph was not to scale, but I have attempted now at least to show you that the 4 was supposed to be there and the 0.5 was supposed to be there. So this shows the journey of a car during the first 5 minutes. Time is always on the horizontal axis. And here you've got the speed, okay, kilometers per minute. All right. So for how long does the car travel at a steady speed? This is just one mark. So you just have to find that where you can see that horizontal line indicates. So 4 minus 0.5, that was just 3.5 minutes. All right. For how long? We are looking for the time there. Then what is the acceleration of the car? Remember, I said acceleration when you deal with speed time graphs is gradient. Gradient is vertical distance divided by horizontal distance. So the very first half a minute, that's 0.5. It's 1.5 divided by 0.5. Then your answer is in kilometers per minute squared. Then calculate the distance traveled by the car. So we are looking for the whole distance. Distance is area under graph. So what I'm going to do, but here they want in first they break it into parts. So we just have to find the distance traveled by the car during the first half a minute, which is 0.5 here, which means you're going to find the area of this triangle. Half times base times height. Half times the height is 1.5. The base is 0.5. Okay, then that is the answer in kilometers. If they ask the whole journey, it is this what we got here, plus this whole rectangle plus that triangle. But the whole thing is a trapezium. So if you can find here the 5 and the 3.5, because the formula to calculate the area for trapezium is you take the sum of the parallel sides times the height and obviously divide that by 2. So you get 6.375, 6 and 3/8, or 51/8. Any one of those I would have accepted as an answer, and that is how that question was supposed to be done. Right, so question 3 brings in another speed time graph. So here you have got a motion of a cheetah chasing a gazelle. All right, so that you have your speed time graph there. So for the first 20 seconds, that's from 0 to 20 here, calculate the cheetah's acceleration. Now it's very straightforward, 30 meters per second divided by 20 seconds. All right, so that is 1.5 meters per second squared. Then the distance moved by the cheetah, remember, for the first 20 seconds, this is still part of that instruction. So it's this distance here of this triangle, half times base times height, so it moved 300 meters. Now you're supposed to say or find the total distance traveled by the cheetah in the first k seconds. So they're telling you that the area of this little trapezium here, okay, is basically 960 meters. Okay, so find the value of k. So I know my 300 was here. So I want to find the value of k. So if this is a rectangle where you have the height is 30 times k minus 20. Why k minus 20? To find that length. Now this is something that is actually very straightforward. All right, people. So if you want, this is the 30 and this is 20. Okay, and suppose this for some good measure it's 50, and I wanted to find what is the distance from here to there? Then I have to say 50 minus 20. Okay, but since I don't know what that distance is, so the simple thing that you do is we replace it by that letter, because we are supposed to find that distance. All right, and what we know here is it is going to be k, whatever k is, minus 20. So it's this distance times that 30 is going to give me this particular distance. So together, the 300 plus this business should add up to 960. Okay, and that is what I have done, and that is what I expected you to be doing. There's a different way, but that is ultimately what it means. So when you are here now, you can actually find the area of the rectangle is 30 times k minus 20, and I can multiply that out. So first I got rid of the 300 by subtracting 300 from both sides, and then I did not multiply the 30 with the k and the negative 20. No need, because 30 can go into 660. Okay, I divided that, so I'm going to get 22. Now, we must make k the subject of the formula, add 20, and that is 42 seconds. And that is how we're supposed to calculate the value of k. Question 4, below is a table of values. This is a brought in graph. The function is 3 over x squared. All right, x cannot equal to 0. That's why you have the dark spot there. You can't get a value for x when x is equal to 0, because division by 0 is not possible. So this graph will be discontinued. There will be a part of the graph, then it breaks, and then the other part will be reflection. Okay, so you had to first calculate the values of s and u and t, and for some reason some of us did not put this stuff in brackets, and because you didn't put them in brackets, you ended up getting wrong values, and because you got wrong values, you ended up having to draw a completely wrong curve, and then you lost the marks there. So please remember that stuff. Anything squared is positive, okay, no matter if it's negative or positive. If you square it, you should get a positive answer. That is something that you should remember. All right, now since we've completed the table, they ask us now to follow this particular specification to draw the graph. So I'm going to go to the next slide, and I'm going to bring my instruction back. So they're saying use a scale of 2 centimeters. We have to represent 0.5 units on the x-axis, 1 centimeters represents 1 unit on the y-axis. Then you have to draw the graph. Now, again, it's always important before I start graphing, I need to be able to know. All right, so I know the x stuff here is going to be from negative 2, negative 0.5 on the left, 0.5 to 2 on the right. And the highest value of y is 12. Looking at my graph, the lowest one is 0.8. So this is what I essentially expect to get. Okay, you might not know how the function look like, but this is what I expect to get. So this is how I know my graph should look like, and can now start, so I can know which part of the graph I can use the graph paper. And maybe to mention again that zero story, some of you had to go and draw lines here. I don't know what you do. These graphs cannot meet because the denominator is 0. The y-axis is the line x equal to 0. That is the equation of the y-axis. So this graph cannot cut through the y-axis. They are going to get closer and closer. We say they get closer and closer. They form an asymptote. They get closer and closer, but they will never cut the y-axis, because the y-axis is the line x equals to 0, and this function x cannot equal to 0. Alright, so I have got my graph paper ready here. I bring my table in, and I also want to determine what does my scales mean on my axes. Alright, so I have got between 0 and my y-axis, okay? So I was supposed to go 1, 2, 3, but I go 2, 4, 6, okay? So I know that one small block represents 0.2, and on my x-axis, one small block represents 0.05. Now, I'm going to start to plot when 2 is 0.8. So all of this is going to be positive. You plot, all right? So I plot the one on the left, and if I then join, that is how that curve will be. So it's going to be a reflection on the other side. So 0.5 is 12, way up there. 1 is 3. 1.5 is 1.3, 2 is 0.8, and then you get that. And so that is the function, and you have solved that question. Now they are saying you're supposed to use your graph when the whole thing is equal to 8. That 8, remember, is y equals to 8. Okay, refer to most of my videos I did on graph of functions. So I brought in the line y equals to 8, and I'm going to read down the x values in estimation. So negative 0.7, and on the other side here about 0.7. So in this case I accepted answers plus or minus 0.6. That means you could have got 0.6, 0.7, okay, or 0.8, 0.7. Okay, in that range I would have accepted the answer. Right, so use your graph now again, something similar to solve 2x plus 6. So what is 2x plus 6 is a straight line, people. So bring in a table, and you can use the whole number values. You only need 2 points to draw a straight line. So I took to -2, -1, 1, and 2. And I'm going to draw that line. So if I punch in -2 here, I get an output of 2. If I punch in -1, I get an output of 4 into the equation and so on. So start plotting the points. -1 is 4, 1,8 all the way here, and 2,10. And then you draw the line. When you draw the line, we are now supposed to find where the two functions are intersecting. So I got x equals -0.9, and the next one here is about x equals to 0.7. Also, there was a range of values between -0.9 and 0.7, but only a few values there, okay, was acceptable. Okay, so be very careful that you do not go beyond that. That means your curve was wrong. Then on this other question that follows, you're supposed to draw a tangent. Now the tangent line had to be like this. It is an estimation, and I expected you to use one of the points that you are given. Okay, so that is with your tangent line. You get a mark. So the next slide, I'm going to show you how to calculate. I'll use my points that I have here. So I have a point 0 for x and about 3,4 there. Okay, so this particular point of mine is 0. If you have a look at it, so this is 0, and the other point is 3,4. Okay, that is what I had here, and obviously I use this 1.5 here. Okay, 1.5 comma, well, that is about 1.3. So this particular point I get from my table. All right. Okay, so I use all those points, and calculating the gradient, definitely I get an answer of something like -1.7, which is more or less where you're supposed to be. Any value between -1.5 and -1.8, I would have accepted that answer. If you know calculus and some reason you want to do A-level next year, we can definitely calculate by differentiating our function, and the gradient of the function would have been -1.8. So this is where this answer is more or less in the region. Right, so the last question here, you were supposed to express 2x squared plus 5x minus 5x plus 3 in vertex form. So you use the axis of symmetry to find the line of symmetry of the function, okay, minus b over 2a. Now remember, if you have to write it in here, it will be the opposite of the sign. And when you take that answer and you punch it into the function, you're going to get your value of q. So my value of a is 2. My p is negative of that, okay, the opposite of that. And my q is whatever I got from there. So you could have written it this way, this form, or even as decimals. Any one of these would do, okay? Any one of these would do. This is exactly what I'm looking for. All right, maybe just to emphasize a little something here. Why is that this is actually similar as that? Remember, if you take the line x equals to 5, the equation x equals 5 over 4. So what you can do, the way we solve equations in algebra, for example, okay, is we're going to multiply first by 4. All right, so I'm going to multiply by 4. So now I have got 4x is equal to 5. And then the next thing is I'm going to subtract 5 from both sides. So 4x minus 5 is equal to 0. Or alternatively, you can just bring that whole thing, all right, over, and you get 0. So that's basically what it means there, okay? And obviously this is also a decimal as 1.25. So again, there you go. Either one of those answers, they exactly mean the same thing, and I expected you by now, after we have covered that topic in full in detail, not to struggle writing it in vertex form using the axis of symmetry, then punching in that in order to get what is your value of q. A is identifiable. The A is identifiable from your standard form. the quadratic 2x squared minus 5x plus 3. The a is identifiable. You can see it's 2, so that is not a problem. But I wanted it in this form, and that is how you were supposed to solve this question.